Hello, hello. All right, I think it is time to begin. Thank you all very, very much for coming. We're absolutely delighted to have you here. This is sort of our dream conference, in a way. I think the invitees and the speakers are, this room is amazing, and I hope we see amazing things throughout the day. So I want to very quickly introduce our first speaker, Giannandrea. He is a senior vice president for engineering at Google. He's in charge of search, assistant, and machine intelligence. He came here in 2010 from MetaWeb, and his work is part of the knowledge graph that Google uses today. And we're incredibly lucky to have him here. I think he's a visionary. And he's going to start us off with some remarks. So thank you.
Thanks, Martin. Good morning. I'll just repeat what Martin said and thank you all for coming. I know you have other things to do with your time, but I think this is a very important topic and something that we're excited to spend time talking about. So what is this pair thing and why does it matter? Well, artificial intelligence is clearly going to have a big impact on our lives. If I can make the slides not go too fast. There's probably, I was talking to some reporters this morning, there's probably not, can we go back one slide? Oh, there we go. It's being slow. There's probably not a vertical industry in our society that's not going to be touched by this technology. And I mean that not in a hyperbolic way. So if you think about the number of people who are using computer systems today, and the vast majority of those systems are actually heuristic and programmed, and over the course of the next decade or so, more of them are going to become learned systems using machine learning and AI. The impact of this technology is going to be huge, and therefore it's important that we get the humanistic aspects of the technology right, that people understand what it is, how to use it, and that we build systems using best practices. So just some random stats here to sort of frame the issues, some of the research issues that we care about. So 1,000 languages spoken is more than this, like 1,300 or something, but worldwide, it's pretty clear that if you want to reach everybody and touch everybody with technology, you really need to understand cultures and languages. Healthcare issues are something that some of our researchers have been working on. There are 400 million people in the world who are at risk of this disease, diabetic retinopathy, and we've published some results where machine learning can actually help with this in a meaningful way because there's not enough eye doctors in the world. And then even on the consumer side, this year there'll be more than 1 trillion photos uploaded from smartphones worldwide. And so what does that even mean? What do we do with all of that information? What do we do with the human capturing of the world? And so these are very impactful examples of how technology is transforming our life. And so I think it's important that we actually research how to do this in the best way that augments humans with this technology. So how do we do that? Well, we started the pair effort this summer, and we're looking broadly at 3 different things. One is for engineers who are working on this technology, what are best practices? Can we help these engineers do good work and build this technology in a way that is very intentional? We strongly believe that these technologies augment humans, that they are not intended to replace human decision makers. Just like the Google search engine, they make us all slightly smarter and more effective. And so what does that mean? How do we best augment people? How do we work with them? How do we build tools that users understand and can help them, like, for example, decision support for a doctor? And then how do we remain inclusive? How do we make sure that this technology is available to everybody and isn't just used by an elite number of people? And what does that actually mean? And what could we actually do about it as a company and as researchers? So that's broadly the things that Pierre is interested in. Today I'm going to talk about 3 different things that I think are very important when you're looking at AI and machine learning technologies. These are interpretability, whether models are actually understandable, controllability, making sure that we build the models we want to build, and then accessibility. I'll talk about what we do to make sure this technology is available to everybody. So let's start with interpretability. So here's an interesting example from our neural machine translation work that we published. last year. So we've recently revamped all of our machine translation tools at Google with advanced neural machine learning. And so here's an example of taking a piece of Hemingway and translating it into Japanese and then back to English. And it's almost perfect, but you can see that there's a couple of words here, the ones in teal, which are missing in the back translation. And so here you have this incredibly powerful thing translating between two languages, but it's not quite right. Now, how would you know what's going on inside this model? How would you have any understanding about how you might make this better or how important this change, this error could actually be? So here's an example of a two-dimensional visualization of a language model that was built with this neural machine translation thing. And you can see there's different clusters for different parts of the model. But what's going on here up in the top right is that there's a little cluster related to some sentences. And then below that, we've broken out the sentences and color-coded them into English, Korean, and Japanese. And what you can see is that even though there are very different grammars and very, very different language structures for these three sentences, they've actually all clustered together in this high-dimensional space. So this is a really interesting example of how you might debug such a model and inspect it. And in fact, the researchers looking at this think that this is early evidence of some kind of interlingua that they could inspect. So that's kind of interesting and an example of the kind of research inspectability that I'm talking about. Here's another example paper we published this year on something called integrated gradients. And the question here is the deep neural network has decided that this picture on the left is of a fireboat. And so the question is, what is it in that picture that makes it a fireboat, right? And so the picture on the right is showing you that the general shape of the boat plus the water streams seem to be the salient feature that this model seems to have learned. And you can visualize it in this way, and you can try and correct for your training data. So that's interpretability. I would say we're just sort of getting started on this. Today, a lot of these models are fairly opaque. And so, some people talk about doing neuroscience for deep learning, but I mean, I think we do need to invest in tools to understand the models that we're learning. And then, how do we control the models that we're learning? So controllability. Well, the most obvious one right now is that almost all of these machine learning systems are learned from supervised data. So large amounts of labeled data labeled by humans given to the system. So obviously, it's super important that the labeled data be good, right? That it not be biased, that it include all the cases you care about, and so on and so forth. So we've been putting a lot more effort into this notion of representative data sets. Like, how do we know that the training data we're giving the systems will get the outcome that we actually want? And so it's very important that you have inclusive data, you have unbiased data, and so on and so forth. And so the pair researchers have been working on tools to help researchers inspect the data that they're actually using. So this is a faceting tool that can actually show you the data by different criteria, and so you can tell whether you have, in fact, a good set of training data and whether you actually have all the cases covered and whether you need more data for one facet or another. And we're just beginning to build these kinds of tools. We open sourced this one earlier this year, but we think this kind of tool, which is used by researchers internally, is super important to make sure that the data you're training on is inclusive. Here's an interesting example from the Quick Draw research project we did, where we basically had people worldwide draw sketches. We would say, draw a sketch of a chair. And we got about 800 million submissions from 100 countries, which kind of surprised us, but it was cool. And so if you dig into this data, it's kind of interesting because it turns out that on average in different cultures and different countries, people actually draw different stick figures of a chair. So you can actually see some kind of cultural variation in the people who are using this tool. So if you were trying to teach a computer how to draw a chair, you might be interested in this kind of diversity in the model. And then more sort of seriously, in some sense, when you're building training models, you can actually put constraints into the model that you're actually learning. And so this is some research we've done where by adding constraints to the model, you actually get a better and more accurate model. And so this is also fairly recent research from one of our research groups. And get the next slide, maybe. I know it's going to go 2 slides forward here. Okay, yes, I knew that was going to happen. All right. And so finally, as an example, I wanted to show you from internal research from YouTube, where researchers were building a model to recommend videos that you might want to watch based on videos you were already watching. And what was interesting about this piece of work was that the original model basically just looked at the number of watches of a video, right? That was the primary variable it was looking at, and that's fine, but that would give you different results for frequent users than for casual users. And so when the model was refined to weigh each user and the applicability of the recommendations for the user over the user's lifetime, what happened is you got much better recommendations for users. So by putting the user in the equation, by thinking about not just the frequency of clicks, but actually the lifetime value to the user of these video watches, you get much better results. So accessibility. So I said at the beginning that we want to make this technology as widely available as possible. So the first thing we did was we open sourced TensorFlow, which is the set of software we use internally to Google. And by and large, we open source almost everything we're using. All of the research we do is published. We have the Google Research blog and so on and so forth. The picture of the cow here is to represent one of the many myriad of startups that have started to use TensorFlow to do interesting things in the world that we as an internet company would never get to. So there's been people using TensorFlow to count sea manatees off the coast of Australia. There's somebody who built a cucumber sorting machine for their parents in Japan. And this is a startup in Amsterdam which is using machine learning to track the husbandry of cows to make farming more efficient in Amsterdam. But generally, these are use cases that we would never have thought of and happen because we open source the technology. Another thing we're excited about is something we call AutoML, or learning to learn. Today, machine learning is somewhat of an empirical science, which means that you really have to have like a world-class researcher who is actually setting up the model, deciding what the learning rate should be, figuring out what the taxonomy of the model should be. And that's clearly a problem because there's only so many machine learning PhDs in the world. So we've been asking the question, can we use computers to figure out how to do machine learning automatically? And so here what's going on is a machine learning model has been going through a bunch of different potential models, finding the one that that performs best. And this is very computationally expensive, but you can see here in the red line that the AutoML model for this particular task has produced the best answer. And this is exciting for us when you combine this with cloud computing, because then in theory every company that has a problem that would apply which machine learning could help with will have access to these best in class models. And so that seems important if you want to scale the impact of this stuff. And we do fun things as well. So we have this AIY project where we let people in the maker community have access to the latest technology. So this is a project where you can build a Google Home device in a cardboard box. It's a lot of fun, no soldering required. But the idea here is just to get educators and people familiar with leading edge technology and recognizing that it can work on something like a Raspberry Pi. And later today, you're going to hear from Doug Eck about some really interesting work that's going on in music and the arts using generative models. So machine learning can actually produce things based on sequences it's consumed. And so there's all kinds of interesting applications of this in the artistic realm. And this is also something that I think humanizes this technology and lets people understand it changes people's perception of what the computer can actually do when it can compose and play music. And finally, here's an example that we're pretty proud of. This is a project we did together with the Gina Davis Institute in LA. Some computer vision researchers learned that Gina Davis, the actress, has this institute where they were trying to figure out gender bias in movies and television. And the way they were doing it was with graduate students who would watch movies and write down the appearance of women and male characters in movies. And so obviously this is something that machine learning can do a good job of. So we worked together with them, and there's some open source software that can watch a movie and in detail not just track the appearance of male and female characters, but also the amount of time that each character is speaking or is the principal in the scene. And so they're able to run this on many decades of top grossing movies. And what they learned was that movies that have a strong female lead or a strong female and male co-lead actually do better at the box office. And so the people running the movie studios and the TV studios have sort of paid attention to that, and now you're seeing a lot more TV and movies that are being made with strong female leads. And I think this is super important because if you think about a child growing up today, watching television, watching YouTube, watching movies, if they're fed a diet of biased data, then what does that say about our society? So I think we're just getting started. I think this technology has just begun to become a high-profile thing. I think it's really incumbent on technology companies in this space to make sure that people who are building this technology understand how to do it in a responsible way, and the people who are using these tools are not afraid of them, but understand how they work and how they can augment their decision-making. And finally, I think we have to make this stuff as available as widely as possible so that everybody in the world who has good ideas about how to use machine learning and AI has access to the technology. And so we're committed to playing our part, and PAIR is a big part of our investment in this space. All right, I want to invite Martin and Fernanda back up here to tell you about the day.